Anatech tabletop reactive ion etching system. This system is a tabletop mountable unit with a handheld controller, and soon after power off, the controller comes up the screen, and then we can select menu and go to the various menus. It says select recipe, and only one recipe is there in the unit right now. And to review a recipe, move up or down arrows to review a recipe and press enter, and we can see the parameters. Pump down is the base pressure to which the chamber will be pumped down, and the time it takes to pump down, which is adjustable in the modify program menu. And press menu here, we see the power level and pressure set at 120 millitorr, and this is the step duration, which is actually the process duration. And then there are 4 MFCs. We can turn on any of them as desired. In the current recipe, gas 2 is selected, MFC at 6%, and then gas 4. The heater and bias option are not enabled in this unit. The system is very simple, with a vacuum valve and then a pressure controller, which controls the exhaust gases or the pumped down gases, which is in the vacuum line. And there's a RF generator, RF5S plasma products, and there's a matching network controller. And the handheld unit is connected to the 25-pin port. And in order to go back to the main screen, we can press menu and enter. We go to the screen here, the second screen, where the process recipe can be selected, and you press enter, the system will start running the process. And if you go to manual run, manually the unit can be operated. So I'm going to select manual run just to demonstrate, and it asks for the password, which is 1234. You press enter, the password is accepted. And to go to the individual parameter, you can press tab here. So I'm going to vent the chamber. Currently the chamber is under vacuum, so by pressing plus we can turn on the vent, and the chamber will be vented. So the chamber is vented manually, and you press minus to turn off the vent. Now there's a chamber door can be opened like that. That was a wafer, 8-inch wafer. I'm going to load the 4 5-inch wafers on the chuck. Here this is just for demonstration, and the upper electrode is perforated, and the argon gas or whatever the reactive gas we connect to the system will be ejected through the perforations here. It is like a shower head. Both the upper electrode, the upper electrode and the bottom electrode are water cooled. Now I connected the system to a OptiTemp standalone water chiller unit. So coming to the handheld controller, once we enter the password in one of the screens, modify a recipe, the screen state goes into the recipe modification screen, and here by pressing tab we can move the cursor and then enter a digit. Any digit to be changed, you have to move the cursor to that location by pressing these arrows. Now to go to the next screen, we press menu and then press tab to go to the specific parameter here. So once it is done, I go to the main screen by pressing stop, and now the argon gas is connected to the chamber MFCs. Now I'm going to start the process by pressing enter when the cursor is on process recipe. This system is installed without a pump, but once a proper pump is selected, and right now the process execution is taking place. The pressure sensor on the chamber is a MKS 127 series baritone capacitance manometer, and its range is 0 to 1 torr. So the reading on the unit will start to change when the pressure inside the chamber goes below 1 torr. And this is the first step of the program 1 here, and it's indicated that its pump down sequence is on, and the pressure is going down quickly. So as soon as the pressure goes down to 30 millitorr, which is the set target pressure level or the vacuum level, here the RF generator is in the mode to set the set point from the handheld controller, so we can set a range from 0 to 500 watts in the handheld controller. And the matching network controllers for the load and tune selections, the upper selector switches are in auto mode, and the bottom switches are for manually adjusting the capacitor positions. So in manual mode, so the toggle switch should be in the middle position. And once you put it in the middle position, we can move it to right or left, and that specific cap will be adjusted. So now the chamber is pumping down, and the pressure regulator will start only once the pump down vacuum level goes below 30 millitorr. So the set chamber base pressure level is 30 millitorr, and once it reaches 30 millitorr, the gas flow will begin. Right now the gas flow started, and the target pressure for the process pressure is 120 millitorr, and the throttle valve will start to regulate the right now the target pressure is reached and the RF power is enabled, which is 200 watts. The forward power is 200 to 201 watts and the reflected is 0. And the timer will begin. The handheld controller is not immune to the RF noise. So for normal operation, if the handheld controller is away from the system while the plasma is on, it will work better. If the handheld controller is left on the chamber while the process is running, the possibility of the controller lockup is more because of the induced RF noise. Timer is up for the process. The system will start pump down again, and this time it will pump it down to 10 millitorr, and it is step 2. After that, and there is another 3 minutes of pump down at that pressure level. After that, the chamber vent sequence will begin, and once the chamber is vented using the vent gas, either dry nitrogen or compressed air at about 25 psi, the chamber door will under the process chamber, this is the vacuum valve manifold. These valves for the gas enabled valves, and the vent valve and the vacuum valve are all pneumatic valves. This is the Veritron pressure transmitter. We have the main roughing valve here. And these are the water lines, and the water flow switch is right here. And right now the float is up. So if the water flow direction is not correct, then the water dripping will start and the float will never go up. And when the water flow switch is not enabled, we cannot run the process. The system will prompt that water flow error. And this is the matching network controller. The RF goes in, and inside this shield is the connection, the RF output to the electrode, the bottom electrode. And this is the cable coming from the matching network controller. And this is the chamber gas inlet, which is connected to the inlet port on the top of the chamber over here. At any point of the time, pressing the stop key twice will bring to this screen, and you press it second time, we can vent the chamber. So once the chamber is vented, it will prompt to continue to open the door. So there's no mechanism to hold the door up. It's very heavy, and the danger of the finger pinching point is at the door, so while lifting the door, hold it firmly, or we can rest the door on the back like that, and you can go with this, replacing the sample. The gas pressure control is better with the optimized flow in the MFCs. Right now I have a pressure setting of 100 millitorr, and the error signal is indicating in the green zone, which is almost zero. So the valve is almost fully open, about 85%, and it is regulating. If I increase the pressure, this valve position will shift to the left, and it will be about 50% if the flow is adequate. So the set pressure range is about 100 millitorr, and it is indicating 96 millitorr. And the pressure signal from the transmitter goes to the pressure controller before it is read on the handheld controller here.